This call is now being recorded.
Correct. இப்போ எதாவது எக்கோ வருதாப்பா? இல்லை இல்லை.
No, sir, recover, sir.
So the electrical energy, right? So it is driven by the electrical motor, right? So the hybrid electrical vehicles will be driven by the electrical motors, right? So just wait. Okay. So the driven structure it depends on the drive train structure, right? So it is designated between the parallel connection or a series connection or a combination of the energies connection, right? That is the combination of the hybrid electrical vehicle connection, right? So, and one more thing, it is depends on the share of the electrical motor to the traction power, right? Share of the electrical motor to the traction power also, right? So it will be distinguished between either we have to use the mild or a micro hybrid types or not, that one. Then the power assisted hybrid, then the full hybrid will be there, right? So these are all how the electrical motors will be gives the supply to the driven chain drive, right? So that we have to see in the detailed manner, right? So generally it will be depends on the nature of the electrical source, right? Nature of the electrical source. So how the electrical source will be gets into the drive, right? So either it may be in the combustion of the fuel or a fuel cells or the hydraulic or pneumatic power or the human power, right? So how the electrical power will be generated in the hybrid electrical vehicles, right? So that's a combustion system of the hybrid electrical vehicle system, right? So in the system, first we have to see so these are the basic about the hybrid electrical system. You can see here in the conventional type of vehicles, the first one, the conventional is there, right? So here you can see the fuel will supplies to the engine, then the engine will runs and it will transmit power to the transmission system, right? Is it correct or not, right? So that is the conventional type of the system. Then the second one is the purely the battery, right? So purely in the battery, right? So the battery will runs the vehicle, right? So the battery will gives the supply to the electrical motor, then that electrical motor will connects to the transmission system, then it will transmit the power, to the traction system, right? So that is the second one. Then what about the hybrid vehicles? Means the combination of these two, the conventional battery vehicles as well as the hybrid electric the conventional battery and the IC engines, right? So both will be connected, right? So both will be placed in a single type of system, right? So that type of system is called the hybrid electric cars, right? So it is a basic about the how the electrical power will be given to the hybrid electrical vehicles, right? Then first we have to see how the hybrid will be works, right? That we can see in the first, then we can see that the hybrid section, right? How that will be works, right? So in the type, so here you can see how the connection will be there, right? So this type of hybrid is called the series type of hybrid, right? So this series type of hybrid, it is one type of the hybrid system. It is one type of the hybrid power power driven system to the vehicle, right? So here in this series type of hybrid system, right? So the combustion engine drives the electrical generator, then the instead of the directly driven by the wheels, right? So we have to run the IC engine, we have to run the IC engine. The combustion will be takes place in the IC engine, that IC engine will be connected to the generator, then the generator produces the power and it will be stored in a battery, or it may be transmit to the transmission system, that is the electromotor system, by using some inverters, or when the power supply will be needed. So there we can give the energy from the engine as well as the battery, right? So in this diagram here you can see what will happen. So here the it is the IC engine, right? The IC engine will runs the generator, right? So the IC engine will be using for generating the power, right? So the generator will generate the power electricity, and that will be goes into the inverter system, and it will be goes to the driven system, right? That is the electrical motor will be connected to the transmission system. Then the transmission system will be a dry power system, right? So here just wait. Okay. uh, so in the series type of system, right? In the series type of system, so the hybrid the series hybrid system, the
Presentation.
just wait. Is it the
Left side. இப்போ ஓகே சார், இப்போ ஓகே.
okay, right? So in the system you may see the electric motor is only means of providing power to the wheels, right? So here you can see the only the yellow color will indicate the motor, that the electric motor is only means of providing the power to the wheel system, that is the transmission system, right? So here the generator both charges the battery as well as it will give power to the electrical motor also, right? So here you can see the generator will the generator will generate the power, and it will be passes through in the form of the battery, right? It will goes to the battery as well as it will goes to the electrical motor, right? So when the large amount of power are required, the motor draws the electricity from the both battery as well as the generator, right? So when the power requirement is more, right? So on the time, so what will happen, the electrical motor will draw the electricity from the generator as well as the battery, right? So this type of system is called the series hybrid system. This type of system is called the series hybrid system. Is it clear? It's a very simple one, right? It's a very simple one. So here we have a IC engine setup also there, and the battery also there, right? So in that IC engine system will runs by the fuel. So either system we are using the fuel cells also, right? So last class we have seen about the fuel cells. So there we can see the fuel cells also. So either we are using the IC engines or the fuel cells, right? So that is one type of source, and the second type source will be the battery. The second type source will be the battery, right? So here we are using the two types of sources. So for that only it is called as the hybrid type of vehicle. It is called as the hybrid type of vehicle. So either we have to use first source or a second source, right? So here its working will be very simple, right? Its working will be a very simple one. So the electrical power, how the electrical power will be generated, then how the electrical power will be supplies to the electrical motor, which is driven by how the electrical motor will runs the vehicle, right? So this is called the series type of hybrid system. This is called the series type of hybrid system, right? So in this series hybrid system, the series hybrid system is already exists for a long time, right? Already exists for a long time. You may see most of the diesel electric locomotives are there, and then the hydraulic earth moving machines are there, then the hydraulic power groups are there. So the loaders, right? So there we are using this type of drive system, right? Here we are using this type of the drive system in many terms, right? So here we have to use one more, the power driven system, that is called the ultra caps. That is called the ultra caps. So what is that ultra caps, right? So the series hybrids can assisted by some ultra caps, that is the energy from the flywheels or the kinetic energy repulsion system will be there, right? So that we can see in the next class. We can I can explain that one, right? Then the delivery peak energy during the acceleration and take some regenerative energy during the braking system, right? So you may note this point. um, how the efficiency will improve, right? Then how we can reduce the losses in the hybrid system, right? So that you have to note this one. So how the efficiency will be increased by minimizing the losses of the battery, right? So here the efficiency, right? So if you are charging the battery and the battery, how much of capacity will be there in the battery, then how much of kilometer the vehicle will be runs, right? So depend upon this we have to calculate the efficiency, right? So if the vehicle will be runs in a particular kilometer at a particular charge of the battery, the D drain of the battery, right? So if the battery drains from 100 to 80 percentage, then how much amount of how much kilometer will the vehicle will be runs, right? So depending upon the battery drain we are calculating the efficiency, right? We are calculating the efficiency. Then how we can improve the efficiency base by means of by reducing the losses in the battery, by reducing the losses in the battery, so we can improve the efficiency in the hybrid type of vehicles, right? So here they deliver the peak energy during the acceleration, right? So during the acceleration the battery, from the battery to the driving system, driving motor, so it will delivers the peak energy, right? It will delivers the peak energy. At the same time if you are applying the brake, right, if you are applying the brake on the time, what will happen, the regenerative energy has to take, the regenerative energy has to take, right? So then only what will happen, the battery drains will be the optimizing, right? So therefore the ultra cap systems, right, therefore the ultra cap systems will be used here, right? So the ultra cap system kept charged at low speed and almost empty for the top speed, right? The ultra cap system or kept for charged at the low speed and almost empty at the top speed, right? So deep cycling of the battery is reduced, right? The deep cycling of the battery is reduced, the stress factor of the battery is lowered. So the ultra capping system will assist in the hybrid system, so it will give some benefits, right? It will give some benefits. So the complex transmission system between the motors and the flywheels are not needed in this type of system, right? So the electrical motors are efficient over the wide range of the speeds, right? So if the motor is attached to the vehicle body, then the flexible couplings are required, right? So these are all the advantages and the disadvantages, so both are the mixed here, right? Then while the vehicles designs have the separate electrical motor for the each wheels, right? So some vehicles will have uh, each wheel will have the separate motors, right? So the motor integration into the wheels has a disadvantage one, right? So if it is in centralized one means it may give some equal transmission to all the wheels, right? But if it is separated in a particular wheel, right? So each wheel will have a separate electrical motor means it's a very disadvantage. So unspring mass will be increases, right? So the balance will be diminishes, right? So due to the balance dismissal, the unsprung masses will be increases. So the decreasing the ride performance, right? It will decreasing the ride performance, right? So when the advantage of the individual wheel motors includes the simplified transition system, right? So if we are connecting each motor into the each wheel, right? So what will happen? So it will simplify the traction control, but at the same time, what will happen means the unbalanced motion will be occurs. So due to the unbalanced motion, what will happen means we can decreasing the ride performance, right? So here the advantage is there and the disadvantage also there, right? So each the electrical motor. So for example, if we are having the four wheels, so for four wheels we are attaching the separate four motors means there is an the traction control will be easy. Uh, the simplified structure will be there, but it may gives the fluctuation on each wheel, right? So there is a lot of fluctuation will be there between the rotation of the wheels. So what will happen there? The riding performance will be differs, right? There is there the riding performance will be differs. So obviously what will happen? The efficiency of the vehicle will be reduces, right? So this type of system is a uh, series hybrid system, right? So here we have one more system, that is a parallel hybrid system, right? So in that parallel hybrid system, both the IC engines and the electrical motor, so parallelly connected to the mechanical transmission system, right? It's parallelly connected to the mechanical transmission system, right? So here you can see so how the parallel connection will be there, right? So from the battery itself we are connecting the electric motor. From the here the coupling will also runs the transmission motor, right? So this type of transmission, right? So this type of transmission is called the parallel hybrid transmission system, right? So the most design combines the large electrical generator and motor into the one unit, right? So often located between the combustion engine and the transmission, replacing the both conventional starter motor and the alternator, right? So this will be connected here, right? So here the battery can be recharged during the regenerative braking, right? So regenerative braking, in the during of the regenerative braking, the battery will be recharged, right? So during the crushing, so what will happen when the IC engine power is higher than the required power, right? So higher here the IC engine power, right? So IC engine will develop the power, and that power will be when it is higher than the required, then it will be supplies to the battery. So then also the battery will be charged, right? So there also the battery will be charged, right? So as there is a fixed mechanical link between the wheels and the motor, right? So there is a fixed mechanical links will be there, right? So between the wheels and the electrical motor, but here there is no clutch system, right? So the battery cannot charge when the car is not moving, right? So once if the car will be moving, right, so then only the battery will be gets charged, otherwise it will not get charged, right? So this type of system is called the parallel hybrid system, right? So here also we have some advantages and the disadvantages. Then the series and parallel, the combination of the both, right? The combination of the both system will be the right to the combination of the series hybrid system and the parallel hybrid system. The working will be the same. The working will be same in the series and the parallel hybrid system. Right. So here, what are the components are there, right? So what are the components are there in the IC engine? In the hybrid electrical vehicle system, right? So I already told that. So here we have two sources, right? So for the hybrid electrical vehicles, right? So for the conventional vehicle means we are using the engines, right? We are using the engine, and it will drives the transmission system. It will drive the transmission system. But in battery vehicles, from the battery, and it will be connected to the electrical motor, then it will run the vehicle, right? So for the hybrid vehicles, here we are using the battery as well as the engine system, right? So here we are using the both type of the parts, right? So here the engine also used, right? So most probably we are using the gases, and the petrol engines will be used more in the hybrid electrical vehicles, right? Then we have the battery system also, right? So here we have some battery system also. Then instead of the engine, we are using the fuel cells also, right? We are using the fuel cells also, right? So the major components will be the battery and the engine and the fuel cell, right? So either we have to use the IC engine or a fuel cell, right? So to run the electrical motor, right? So this motor will it is an important part of a hybrid electrical vehicle, right? So due to this electrical motor, it will transmit the power to the driving system, right? It will transmit the power to the driving system, right? So then the controller, right? So it's a here in the most of the electrical vehicle, right? So in the most of the electrical vehicles, nowadays in the modern technology we are using the ECU unit, right? So for the why we are using the ECU unit means it will controls the performance, right? So how much amount of fuel has to supply, right? Then how much amount of actual fuel has to supply, and it will sense the various input parameters to the ECU unit, and the ECU unit will control the engine performance, right? So here also the control has to given to the controller unit, right? So how much amount of power, so when the acceleration pedal will be acceleration will be there, so there we have to give some peak voltage to the motor, right? So on the time what will happen, we have to give some more acceleration pedal, so there the peak electrical supply will has to give to the electrical motor. So how it will be it will be gives the peak electrical voltage means by using the controller kit, right? So the controller kit will charges the battery or to the to the supply to the power system to the electrical motor, right? So from the battery or the inverter or from the engine transmission system, right? So it will convert, right? It will convert the battery direct charge to the chopped DC power, right? So why it is chopped means its power will be like this, right? So its power will be like this, its structure, right? So when in a lower bottom line, when it is in a lower bottom line, so there is some discharge will be there, then where the upper line will be there, that the peak voltage will be there, right? So it is the amplified one, right? It is the amplified one, so it will amplifies and the frequency will be vary. So based on this frequency and based on the voltage input level, then based on the requirement, it will supplies the how much electricity will be goes to the electrical motor, right? So it will control all the terms, right? So the control is a important unit of the hybrid electrical vehicles. Then the generator, right? So if you are using the hybrid electrical vehicles, the two sources, right? So if you are using the either in the IC engines means, so from the IC engine, so what will happen, it will generate the mechanical power, right? Then the mechanical power is converted into the electrical power, then it will be goes to the electrical motor or it will be goes to the battery system, right? So for the storing one, right? So here we have to generate the electrical motor by using the IC engines, but how it can be converted as the electrical energy by using the generator device. By using the generator device, we have to convert the energy, right? We have to convert the energy in the form of the mechanical energy into the electrical energy. So the generator also here the important part of the IC engine, hybrid electrical vehicles, right? So here the general advantage of the hybrid electrical vehicles will be the fuel economy, right? So there is no fuel, so if you are using the fuel into the IC engine means, so the IC engine will runs the generator, right? So the IC engine will runs the generator, not a whole vehicle. So here automatically what will happen, the fuel economy will be very low, very low. At the same time, if the fuel consumption will be low, it will produce the emissions also low, right? So if it is for the IC engine control, if it is in battery unit, so there is no pollution, right? There is no pollution, so there is no emissions also, right? So while comparing the hybrid vehicles, we are using the two source, so for that only the emissions will be denoted as the low emission, right? So at the same time, if the engine will be runs under the high load condition, then only the noise will be high, right? So if it is run by a small energy, reduced ones, right? At the same time, it is safe to drive, right? So these are all the major advantage of the hybrid electrical vehicles. Then so what are the disadvantages are there, right? So the initial cost will be high, and then well, comparatively for the diesel engines or the petrol engines, so here the transmission power will be low. Then for the batteries, right? So for the transmission system, its maintenance cost will be less, right? So here you can see, right? So in the advantage I mentioned here, it is low maintenance, right? Here it is, I mentioned low maintenance, and here the disadvantage I mentioned as here the costly maintenance, right? So what is the difference between the low maintenance and the costly maintenance, right? Right. So if you are using the IC engines, with that the mechanical element will be more, so there is a lot of complication structure will be there in the conventional IC engine vehicles. But in the electrical vehicle engine, so there is no such type of elements, right? There is no such type of elements will be there, so the advantage will be, and the maintenance cost will be low, right? So when well, comparing to the IC engine, while comparing to the conventional engine, it is advantage one. But here the maintenance costly maintenance will be there. How the costly maintenance will be there means the battery, right? So if you are maintaining the battery, or if you have to replace the battery, means the maintenance cost will be high, right? So it is the disadvantages also, right? Then here in this type of hybrid engines, so we have to spend more expensive components, right? So if we are using the generator, so here the maintenance cost will be high, then the spare parts cost will be high, right? So this type of disadvantages will be there in the hybrid electrical vehicles, right? So far I conclude here the hybrid electrical vehicles, right? So remaining terms we can see in the next class. So sorry for in this class we have some technical issues, so we have some difficulties in this class. So next class we can resolve that technical issues, and I can present once again the same to the next class. Okay, right? So up to this, do you have any doubt in this class?